All right, last question, and this one's going to have the most steps. This is imaginary numbers. If you were to see this on the SAT, it would likely be one of the hardest questions on the test, just because there's a lot of steps. However, it is something that I'm sure your Algebra 2 teacher walked you through. We're going to do something called rationalize the denominator, and we're going to rationalize using a complex conjugate. So let me show you all the steps, how we're going to do this. I don't think there's much of a shortcut to this one. I think you just have to work through the math. So we cannot leave the problem just the way it is, because we have a rule in math that says you cannot leave a square root in the denominator. And because I represents the square root of -1, you cannot leave an I in the denominator. So when I have a denominator with I, and it happens to be a binomial, so there's another term in addition, that 8 is in addition to the 3i, I'm going to have to cancel using what's called the conjugate. The conjugate means multiply it by something that's exactly the same, except if this is a minus, you change it to a plus. And if it started as a plus, we're going to change it to a minus. And you'll see the magic of the conjugate as soon as I FOIL this out. Now we're going to use the rule of math that says whatever I do to the bottom, I have to do exactly the same thing to the top. So I'm going to multiply the top by 8 plus 3i, and effectively I'm just multiplying this fraction by the number 1 because it's the equal numerator and denominator. It's just going to change the format of the fraction. It's going to simplify it for me, but it's not going to change the value. And we're going to do this by FOILing. 4 times 8 is 32. Plus 12i, plus 24i, plus 9i squared will be your numerator. Our denominator, 8 times 8 is 64, plus 24i, minus 24i, minus 9a squared. All right. So first of all, what I love is this plus 24i and minus 24i. That's the magic of the conjugate. It makes the I, those middle terms, the outers and the inners, it makes them cancel each other out every time. That's what a conjugate is for. And that's why we use it to rationalize this denominator. Now this I right here, I know we were trying to get all the i's out of the denominator, but we did because I squared is equal to -1. So I can change the numerator to 32 plus, let's see, 12 plus 24 is 36i. Now this is going to change to minus 9 because remember that I squared is a -1. And in the denominator, I'm going to have a 64 plus 9. It used to be minus 9i squared, so I'm going to change that minus to a plus. And finally, it's going to be 32 minus 9 is 23 plus 36i over 64 plus 9 is 73. Let's go and look at the answers. I love that match. It does look like the final answer is separated into 2 terms. Well, that's okay. You can separate it out. It's sort of like the opposite of adding 2 fractions. It's like taking 1 fraction and pulling it apart into 2 fractions. But it's absolutely fine to write it in this way just by doubling up on the denominator. And that was the format for our option D. And you didn't have to rewrite it. As long as you can just see that those 2 equations are equivalent, then you're good with question 6.